First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this today's live lecture, we shall discuss the Routh's procedure. See this, we shall study the Routh's procedure, Routh's function. This is the next part of our syllabus. In this second unit, we have completed the Lagrange's equation from Hamiltonian principle. Now we have to complete these three bits, that is the Routh procedure, Hamilton's equation from the variation principle, and principle of least action. That means we have to complete all these three parts. So today we shall complete the Routh's procedure. Already we know that the Hamiltonian, the function Hamiltonian, which is denoted by h and defined as h is equals to summation over j into qj dot into pj minus l. Same process we have to express the Routh's function also. These are the basic definitions regarding the Hamiltonian function. We know that the Hamiltonian canonical form is this. Now we shall discuss some important notes here. Which are those here? The most often remarks, see this, most often the Hamiltonian procedure gives identically the same equation of the motion as the Lagrange's equation or Lagrange's procedure, and provided you must write all these notes here, and provided no new information. That means Hamiltonian equation of a motion is similar to the Lagrange's equation of a motion. It is also more lengthy and tedious than the Lagrange's procedure. To solve the Hamiltonian equation of a motion, which is the lengthy process, as like a Hamiltonian Lagrange's equation, but the results are same. Exception, the Hamiltonian method is very well adapted to the treatment of problems involving cyclic coordinates. If there exist cyclic coordinates, then we can solve that problems very well by using the Hamiltonian principle. This is the method, note number second. Note number 3, consider the Lagrangian formalization with one cyclic coordinate, suppose say Qn, then the Lagrangian with missing Qn is L is equals to Q1, Q2, Q3 dot Qn minus 1. Remove the Qn. Similarly, Q1 dot, Q2 dot, Q3 dot Qn dot. Remove the Qn. Qn minus Qn is already we have removed from this, and T. All generalized velocities Qi still occurs in L. We still have to solve the problem with n degree of freedom. This implies that n in second order partial differential equation we get. Third, next note, note number 4. On the other hand, consider the Hamiltonian formalism with the cyclic coordinate Qn, the conjugate momentum Pn to the coordinate Q1 is conserved, that is a constant. We define Pn is equals to alpha, which is a constant. Then we get the Hamiltonian H is equals to H of Q1, Q2, Q3 dot Qn minus 1. Similarly, P1, P2 dot Pn minus 1, because Pn is a constant, so its derivative will be 0, alpha, t. So the function of n minus 1 of Qi and n minus 1 of Pi, the problem is reduced from 1 with n degree freedom to 1, that is n minus 1 degree of freedom. So this implies that to n minus 1 of first order differential equation of motion, we can solve the problems completely ignoring Qn except for its time independent Qn. This implies that Qn is truly deserve the description ignorable, because we can ignore in getting the equation of the motion. The time independent of Qn is obtained by integrating the Hamiltonian equation Qn dot, which is equals to dou h by dou Pn, which is equals to 0. So now next we shall discuss the Routh's procedure. What is the concept of a Routh procedure we shall discuss here. Deserve to take advantage of the Hamiltonian methods. Simply we can handle here Hamiltonian method simpler handle to cyclic coordinates, plus to take advantage of a Lagrangian methods simpler treatment of non-cyclic coordinates. That means Routh procedure is the combination of Lagrangian equation and Hamiltonian principle. That is a hybrid, means mixed procedure of Hamiltonian and Lagrangian procedure. Actually Routh procedure is the hybrid or generalization or mixing of Hamiltonian and Lagrangian procedure. See this, consider a problem with non-ignorable coordinates. Suppose q1, q2 dot 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 qs. We have considered s number of generalized coordinates which are non-ignorable, and n minus s means ignorable. So n minus s ignorable coordinates are qs plus 1, qs plus 2 dot 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 qs qn. These are the ignorable coordinates, these are the non-ignorable coordinates. Use the Hamiltonian procedure for n minus s ignorable coordinates, the Lagrangian procedure for s non-ignorable coordinates. Therefore we have to use two procedures. For ignorable coordinates we have to use Hamiltonian procedure, for non-ignorable coordinates we have to use Lagrangian procedure. That means we have to use two procedures, but by using the Routh's procedure we can use only one that procedure and simultaneously we get the result same. Now next note number 6, carry out the Legendre's transformation from the coordinates, that is velocities q comma q dot to the coordinates of a momenta p comma q only for n minus s cyclic coordinates, that is qs plus 1, qs plus 2, qs dot dot dot, getting their equations of a motion using Hamiltonian method, Hamiltonian equation of a motion. For s, for this s which are non-ignorable coordinates q1, q2, q3 dot dot qs are, we have to use Lagrange's motion method and Lagrange's equation of a motion. That means we have to use two different methods. If from q1 to q2 there are s non-ignorable coordinates and s plus 1 to n there are ignorable coordinates, then we have to use two procedure for finding the equation of a motion. First is Hamiltonian equation of motion for ignorable coordinates. Second is a Lagrange's equation of motion for non-ignorable coordinates. So here we have to use two different methods. Do this formally we can use as follows. Now आता हे कंबाइन करायचं असेल, we can use the combinedly both the methods combinedly by using the Routhian function or Rouths function. So we shall define the Rouths function here. How to define this Rouths function here? Suppose Routh function is denoted by R. This is R means which denotes the Routh function. R which is equals to R of Q1, Q2, Q3 dot Qn, comma Q1, Q2, Q3 dot Qs, which are non-ignorable, plus PS1, PS plus 1, PS plus 2, PS plus 1. These are the moment of ignorable coordinates, comma T. So this Rouths function can be denoted by R is equals to summation over, we can write in this way, J such that Pj comma dot Qj dot minus L. This is the Rouths function, definition of the Rouths function. याला असं लिहितात. So Rouths function we can define summation over I is equals to, here we can write Rouths function R is equals to summation over I is equals to S plus 1 to N Pi into Qi dot minus L. This is the Routh function. We can denote this Rouths function equivalently written as R is equals to R of Q1, Q2, Q3 dot Q1, Qn, Q1 dot Q2 dot Qs dot Ps plus 1, Ps plus 2 dot Ps, comma T. So this is the expression for which is equals to, परत याला equals to, R is equals to, this is equivalence to Hamiltonian for cyclic coordinate minus Lagrangian for non-cyclic coordinate. This is a Routh note number 8. ही 8 नंबरची नोट आहे. सेपरेट नोटच्या फॉर्म मध्ये लिहा 1 2 3 4 असं लिहा वाटलं तर तुम्हाला. दिस इज सिरीज. दिस इज नोट नंबर 1. This is note number 1, this is a note number 2, note number 3, this is a note number 4, we can write this note number 5, this is a note number 6, note number 7. These notes are regarding to the Routh's procedure. This is 8, 9, 10. So the equation of the motion of S non-cyclic coordinates, we have the Lagrangian form. This is d by dt of dou r divided by dou qj dot minus dou r divided by dou qj, which is equals to 0. This is the Lagrangian form of Routh's equation. We have to prove this equation. आता आपल्याला हे equation prove करायचे. So this is the equation of a motion in the Lagrangian form. For non-cyclic coordinates, we can write d by dt of dou r by dou qj dot minus dou r by dou qj, which is equals to 0. So next, this is note number 10, the equation of the motion of n-s cyclic coordinates in the Hamiltonian form. We can write QI डॉट इज इक्वल्स टू डो आर अपॉन डो पी आय. तिथं आपण काय लिहिलं होतं पा, डो एच डिवाइड बाय डो क्यू जे विच इज इक्वल्स टू क्यू जे डॉट. सिमिलरली दुसरं इक्वेशन कसं आहे पा, डो एच बाय डो क्यू जे इक्वल्स टू मायनस पी जे डॉट. हे वेगळा फॉर्म आहे, आय मध्ये लिहिलेला आहे. डो एच बाय डो क्यू जे इज इक्वल्स टू मायनस पी जे डॉट which is in the forms here. Dou H by dou Qj which is equals to minus Pj dot. This Hamiltonian canonical form we can write here in the form of a Routh's equation. So dou R by dou Qj equals to minus Pi dot. असं सुद्धा लिहिता येतं. Dou R by dou Qj is equals to minus Pj dot. And dou R by dou Pj is equals to Qj. हे दोन इक्वेशन आहेत which is in the Hamiltonian canonical form. We can represent Routh function in the form of Hamiltonian canonical form in this way. Okay. Next we shall move the problems. Define the Routh function and obtain the Routh's equation of the motion. See here, this is the very important question, very important question. Define the Routh function and obtain the Routh's equation of the motion. So this part is a definition of the Routh function. याला आपण definition of Routh function म्हणतो. See this is a definition. Actually this is the definition. Definition of the Routh function. We have to define a Routh function. And secondly, we have to obtain the Routh's equation of the motion. First of all, we have to define the Routh function. Then we have to write the Routh equation of the motion. Okay. तर ठीक आहे. A function in which velocities q1 dot, q2 dot, q3 dot qk dot. अगोदर आपण नोट मध्ये QS लिहिलं होतं. In the note we have denoted this as a QS. पण आता इथं आपण QK घेतलं. थेरम मध्ये प्रूव्ह करण्यासाठी S च्या ऐवजी K लिहायला सोपं जातं म्हणून QK मध्ये डिफाइन केलं. A function in which velocities q1 dot, q2 dot, q3 dot qk dot corresponding to the ignorable coordinates q1, q2, q3 dot qk are eliminated is Routh's equation, or we get a Routh function. The functions in which velocities q1 dot, q2 dot, q3 dot, qk dot corresponding to the ignorable coordinates, cyclic coordinates q1, q2, q3 dot qk are eliminating from the Lagrange's equation. Then we get another equation, that is we get the Routh equation, or it is called as a Routh function. Routh equation or Routh function, which is denoted by R is equals to R of qk plus 1, qk plus 2, qk plus 3 dot qn. Removed q1, q2, q3 from the Lagrange's function, so we get the Routh equation. हे simple form मध्ये definition लिहिलेले आहे. And it is written as L is equals to L of R is equals to L minus summation J is equals to 1 to K Qj dot minus Pj. Qj dot minus Pj. इथं सेम आहे. ही डेफिनेशन थोड्या वेगळ्या पद्धतीत लिहिलेली आहे. L is equals to S plus 1 to we can write S Pi into Qj dot minus L. This is the another way for expressing for defining the Routh's function. Routh function वेगळ्या फॉर्म मध्ये दाखवलेला इथं आहे. We can define in this way also. R is equals to L. Lagrangian मधून J is equals to 1 to K. हा इग्नोर करा, रिमूव्ह करा. So we get another function. That function is a Routh function. Now proof. आता आपल्याला this is the definition आहे. Definition आहे. Now we have to find the Routh's equation. आपल्याला काय फाइंड आउट करायचे? Routh's equation. So this is a definition of Routh function. Now we have to find the Routh equation of the motion. We have to write the Routh equation of the motion. Here, according to the Routh function, if we eliminate Q1, Q2, Qk from L, then we get a Routh function. R is equals to R of Qk plus 1, Qk plus 2, Q dot 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 Qn, because we have removed up to Q1 to Qk. ही डेफिनेशन सांगते removed ignorable coordinates. Now Q dot K plus 1, Q dot K plus 2 dot 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 in this way. Now we can write delta R. If we differentiate this, summation over J is equals to K plus 1 to N dou R bar by dou Qj into delta Qj, because R is a function of Q. See here, R is equals to R of Qj comma Qj dot comma T, because Routh function is also function of generalized coordinate Qj, generalized velocity Qj dot, and a function of a time t. R is also having a coordinates Qj, Qj dot and t. But note that in that Routh function, ignorable coordinates Q1 to Q2 removed. So here we have to take summation over J is equals to K plus 1 to N dou R bar by dou Qj. आता याचा डेरिवेटिव घ्या. dou R bar by dou Qj into delta Qj plus dou R bar by dou Qj dot into delta Qj dot and dou R bar by dou T into delta T. Suppose this is equation number 1. Also we can express R in terms of L. According to the definition of a Routh function, we can write R is equals to L minus summation over J from 1 to N Qj dot minus Pj. This is according to the definition of Routh function, which is in terms of L. Routh function कसं आहे? लॅग्रांज फंक्शन मधनं इग्नोरेबल कोऑर्डिनेट्स काढून टाका, त्यामुळे जे काही टर्म्स राहतात तो राउथ फंक्शन असतो. सो वी कॅन राइट दिस राउथ फंक्शन इन टर्म्स ऑफ लॅग्रांज फंक्शन. सो नाउ डिफरेंशिएट दिस. डेल्टा आर इज इक्वल्स टू डेल्टा एल minus summation over j is equals to 1 to k. These are the ignorable coordinates from L. आता इथं बाय प्रोडक्ट रूल नुसार वापरा डेरिवेटिव्ह बाय u into v. u into v. So first is it is derivative of second plus second is it is derivative of first. म्हणजे डेरिवेटिव्ह घेतला एल चा डेरिवेटिव्ह डेल्टा आर अँड देन वी हॅव टू टेक अ प्रोडक्ट रूल. इथं पी एन इंटू क्यू ला काय करा, प्रोडक्ट रूल घ्या डेरिवेटिव्हचा. प्रोडक्ट रूल मीन्स फर्स्ट इज इट इज डेरिवेटिव्ह ऑफ सेकंड प्लस सेकंड इज इट इज second is it is derivative of first. In this way we can write derivative. Now separate this summation. So delta r is equals to dou L minus summation over j to k pj into delta qj dot minus summation j is equals to 1 to k qj dot into delta pj. Separate this summation. So consider this as equation number 2. Also we know that the complete Lagrangian function is L is equals to L of qj comma qj dot comma t. Here j is from 1 to n. Note that Lagrangian मध्ये j is equals to 1, 2, 3 dot 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 n असतो. Lagrange's इक्वेशन मध्ये j is equals to 1 to n असतो. राउथ फंक्शन मध्ये 1 to k रिमूव्ह केलेले असतात म्हणून राउथ फंक्शन मध्ये k plus 1 to n. In this way, so we can define separately Lagrange's function. Delta L is equals to dou L by dou qj into delta qj, dou L by dou qj dot into delta qj dot and dou L by dou t into delta t. Suppose this is equation number 3. This is the separate derivative of Lagrange's function. This is the separate derivative of Routh function in terms of Lagrange's function. So put this value. आता पहा, dou L ची व्हॅल्यू इक्वेशन 2 मध्ये ठेवा. Put in 2. Put this delta L in equation 2. Means here we have to put delta here, then we get delta r. So we get delta r is equals to, this is the value of delta L. Delta L मध्ये Lagrangian मध्ये summation j is equals to 1 to n असतो. So this is a Lagrange's function dou L. We have replaced here. We have replaced here. Okay. Minus, this is the value of delta L. This is the value of delta L. Minus this is summation over j is equals to 1 to k pj into delta qj minus summation j is equals to 1 to n delta j. So we can write this. Okay. So minus summation over j is equals to 1 to k pj into delta qj dot minus summation j is equals to 1 to k qj dot minus delta pj. हे सेम बाकीच्या पुढच्या दोन टर्म जसे असतात. These two terms are as it is. We have replaced only delta 2 from equation 3. Equation 3 मधनं replace करा. So we get delta r. Put in 2. 2 मध्ये ठेवलं हे delta L ची व्हॅल्यू 2 मध्ये ठेवली. So now separate this summation because in Lagrangian there are n is equals to 1 to n, j is equals to 1 to n. So summation j is equals to 1 to n dou L by dou qj into delta qj plus summation j is equals to 1 to n dou L by dou qj dot into delta qj plus, आता इथं summation j नाही आहे. थर्ड टर्म मध्ये summation j नसल्यामुळे summation सेपरेट करायची गरज नाही. So dou L by dou t into delta t minus remaining two terms are as it is. So that terms, या ज्या दोन टर्म आहेत त्या दोन टर्म्स as it is ठेवा म्हणजे तुम्हाला या गोष्टी सर्वच्या सर्व माहित होते. ओके. So it will be, now replace this according to the Hamiltonian canonical form. We can replace the value. We can replace these two values. How we replace here? We can replace these values. So delta r is equals to summation over j is equals to 1 to n dou L by dou qj into delta qj plus summation over j is equals to 1 to n pj summation over pj इथं आपण रिप्लेस केला डो एल बाय डो क्यू जे डॉट. See this, we have replaced here according to the Hamiltonian canonical form. Dou L by dou Qj dot means Pj. We have to replace this as a Pj. So we get this Pj into delta Qj dot. Dou L by dou T as it is. That is similar. All terms are remaining as it is. फक्त इथं replace केला. We have replaced this Pj. So delta R is equals to, now see here, the subtraction of these two terms. Summation j is equals to 1 to n Pj into delta Qj dot minus summation, हे subtraction करा यातनं दोन terms same आहेत. Summation j is equals to 1 to n Pj into delta Qj dot minus summation j is equals to 1 to k Pj into delta Qj dot. हे j is equals to 1 to k हे subtraction केलात तर हे subtraction केल्यानंतर कसं येतं पहा, इथं लिहितो मी वाटलं तर summation j is equals to 1 to n Pj into delta Qj dot minus summation j is equals to 1 to k Pj into delta Qj dot. यातले दोन पार्ट होतात, एक पार्ट सेम कॅन्सल होतो, मग कुठून समेशन शिल्लक राहतं. J2 पहिला कसा आहे j is equals to 1 to n आहे आणि दुसरा कसा आहे सेकंड j is equals to 1 to k. 1 to k सबट्रॅक्ट केला तर k plus 1 to n राहतं. This is after subtraction. We can write remaining terms are same as it is, this term as it is, this term as it is, बाकीच्या सर्व term as it is. परंतु हे जे subtraction आहे, this subtraction gives us summation j is equals to k plus 1 to n Pj into delta Qj dot. बाकीच्या terms as it is. हे subtraction आहे पहा, या दोघांचं subtraction आहे. You can make this underline. So remaining term as it is. Now from 1 and 4 comparing the coefficients of delta Qj and delta Qj dot. 1 मध्ये जावा आता, 1 मध्ये compare करा coefficients delta Qj आणि delta Qj dot चे. So we get comparing delta Qj dot and delta Qj, then we get dou R bar by dou Qj which is equals to dou L by dou Qj. Because from equation 1 पहा, equation 1 मध्ये j is equals to 1 to k आहे. So delta Qj dou R bar dou Qj which can be replaced by, so 1 minute. So dou R bar by dou Qj is equals to dou L by dou Qj and dou R bar by dou Qj dot is equals to dou L by dou Qj dot. From 1 and 4 comparing the coefficients of Qj and Qj dot on RHS. So we get dou R bar by dou Qj means dou L by dou Qj. Dou R bar by dou Qj dot means dou L by dou Qj dot. So we get Qj. Okay. So we have the Lagrange's equation of a motion for the generalized coordinates. d by dt of dou L by dou Qj dot minus dou L by dou Qj which is equals to 0 for j is equals to 1 to n. So now replacing this Lagrange's notation in the form of a Routh equation. So dou L by dou Qj which is equals to dou R bar by dou Qj which can be written as dou L by dou Qj dot which is equals to dou R by dou Qj. So Routh's equation we can write d by dt of dou r bar by dou qj minus dou r bar by dou qj, which is equals to 0. This is the j is equals to k plus 1 2. This is the Routh equation of the motion. This is the required Routh's equation of the motion. Here Routh's equation of a motion which can be obtained from the Lagrange's equation of the motion by comparing this. समजतंय का? पाय इथं टी नको आहे, जनरलाइज्ड कोऑर्डिनेट्स लिहायचे डो एल बाय डो क्यू जे डॉट. ओके, सो द रिक्वायर्ड Routh's equation is d by dt of dou r by dou qj dot minus dou r bar by dou qj, which is equals to 0. This is the Routh's equation of motion. This is the Routh equation of motion, but in this Routh's equation we can write j is equals to k plus 1, k plus 2 dot 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 n. So this is the required Routh's equation of motion. This is the Lagrange's equation of motion. We can obtain Lagrange's equation, Routh's equation of motion from Lagrange's equation of motion by eliminating cyclic coordinates q1 to qk, q1 dot to qk dot. So we will get this is the required equation of motion. हे खूप महत्वाचं आहे. This is the define the Routh's function. This is the definition of the Routh function, and this is the required equation. Obtain the Routh's equation from the Lagrange's equation of motion. In this way we can write this is the Lagrange's Routh's equation of motion. ओके, हे एक महत्वाचा थेरम आहे, महत्वाचा प्रॉब्लेम आहे, तुम्हाला व्यवस्थित करावं लागेल. आता एक प्रॉब्लेम आहे पहा. वी शॅल डिस्कस वन प्रॉब्लेम expressed on the central force. Example, the Kepler's example, the Kepler or central force problem. A single particle moving in a plane under a central force F of r, then its potential energy is given by V of r is equals to, here, then its potential energy which is given by V of r is equals to k of minus k r raised to minus n. Nth dimensional system say this. Then, and kinetic energy is 1 by 2 m v square, which is denoted by r dot square plus. So this is a potential energy. Now we know that the kinetic energy, what is the kinetic energy? Which is equals to 1 by 2 m v square. But due to the central force, we can write this as a kinetic energy means T 1 by 2 m into r dot square plus r square theta dot square. This is a kinetic energy. We know that the potential energy, आता potential energy कशी येते पहा. Potential energy we can write the kinetic energy, we can write this kinetic energy. So we can write the potential energy V means minus k into r raised to minus n. So it will be n dimensional system. So now we can write the Lagrangian. How to write the Lagrangian? So Lagrangian L is equals to, according to the definition we have, Lagrangian L is equals to काय रे formula T minus V. We can write this Lagrangian L is equals to T minus V. So according to the put this value L means T means 1 by 2, put this value T means m into r dot square plus r square theta dot square minus V means minus minus plus k into r raised to minus n. So we will write this Lagrangian. According to the Lagrangian, we can explain, we can find Hamiltonian, we can find Rouths. So we have to write the Rouths equations here. So we can write this. according to the conjugate momentum dou L by dou theta dot is p theta dot. So we will get the Hamiltonian equation. तुम्हाला माहित आहे हॅमिल्टन, मी आता हे शॉर्ट मध्ये झालं, हे मी शॉर्ट मध्ये लिहिलं, तुम्ही व्यवस्थित कॅल्क्युलेट करा, फक्त इथे हिंट सांगितलेला आहे. हॅमिल्टोनियन एच कसं लिहिलं जातं, मग पी आर तुम्हाला माहित आहे. फक्त सी दिस, यू कॅन टेक एल, देन कॅल्क्युलेट हॅमिल्टोनियन एच, then calculate Routh, then calculate the Routh equation. R is equals to R comma R p theta. So 2 raised to minus m p theta dot square R square minus 1 by 2 m R dot square into k R raised to n. So this is the Routh equation. Then we know that the Routh equation of a motion from the Lagrange's function d by dt of dou r bar by dou r dot, dou capital R divided by dou r dot. Here the generalized coordinate is r minus dou r bar by dou r. So we get, this is the Routh's equation of a motion which is obtained from the Lagrange's equation of a motion. Similarly, we can find Hamiltonian equation of a motion in this way. So from this we can write, this is the problem which we have calculated in the form of Lagrangian, in the form of Hamiltonian, in the form of a Routh's equation, in the form of a Routh equation. Okay. So this is the Routh equation. हे Routh equation हे तुम्ही व्यवस्थित लिहून घ्या आणि अशा पद्धतीने एक प्रॉब्लेम, एक जनरल प्रॉब्लेम डिस्कस केला. Here in this case we have discussed one general problem, and that problem is Kepler's problem. Due to the central force, we can express this Kepler central problem in the form of Lagrange's. We can obtain the Lagrange's equation of motion according to this. We can obtain the Lagrange's equation of motion according to this, that is dou L d by dt of dou L by dou theta plus dou L by dou. So we can write this as dou L by dou theta dot plus minus dou L by dou theta which is equals to 0. या पद्धतीने आपण इक्वेशन लिहू शकतो, काही अडचण नाही आहे. सो वी विल गेट दिस रिझल्ट. ओके, याला हॅमिल्टोनियन मध्ये लिहून हॅमिल्टोनियन इक्वेशन काढू शकतो. त्यानंतर राउथ्स इक्वेशन मध्ये लिहून राउथ्स इक्वेशन काढू शकतो. डी बाय डी टी ऑफ डो आर बार बाय डो आर डॉट माइनस डो आर बार बाय डो डी बाय डी टी ऑफ dou capital R means Routh function, divided by dou r dot is a generalized coordinate, minus dou r bar by dou r which is equals to 0, and calculate करा. This will be the आता याला कसं लिहिता येईल मग, this will be the Lagrange's equation of the motion. ओके, अशा पद्धतीने हे इक्वेशन तुम्हाला कॅल्क्युलेट करता येईल. पहा कसं कॅल्क्युलेट करावं लागेल रे स्टुडंट्स. पुढे कॅल्क्युलेट करा, याला कसं कॅल्क्युलेट करताय, 1 मिनिट. यालाच असं करता येतं पहा. डी बाय डी टी ऑफ एम आर डॉट मीन्स मायनस एम आर डबल डॉट प्लस डी बाय डी आर, आर चा डेरिव्हेटिव्ह घ्या, काय येईल पहा, मायनस एन k n r raised to minus n minus 1 which is equals to 0. m na divide kara, so we will get r double dot minus k n divided by m r raised to minus n minus 1 which is equals to 0. So the final equation will be, final equation कसं येईल पायाचं, Routh's final equation is r double dot minus kn divided by m into r raised to n plus 1, which is equals to 0. This is the Routh's equation of the motion. This is the Routh's equation of a motion. Similarly, we can find Lagrange's equation of a motion. अशा पद्धतीने आता पी थिटा डॉट्स घेऊन घ्या, व्हॅल्यू ठेवून कॅल्क्युलेट करा. ओके, हॅमिल्टोनियन सुद्धा कॅल्क्युलेट करता येतं. सो वी शॅल स्टॉप हिअर. काही अडचण आली तर पहा, हे सुटसुटीत सिम्पल सॉल्व करा. एक प्रॉब्लेम तिन्ही मेथडनं सॉल्व करा म्हणजे येऊन जाईल. नाउ वी शॅल स्टॉप हिअर. नमस्कार, गुड बाय. काही अडचण आली सर विचारा. इफ यू हॅव एनी डाऊट देन यू कॅन राईट, यू कॅन आस्क मी. सी दिस इज अ व्हेरी इम्पॉर्टंट थेरम. हा खूप महत्त्वाचा थेरम आहे. पार्ट डिफाईन राउथ्स फंक्शन अँड ऑब्टेन द इक्वेशन, राउथ्स इक्वेशन ऑफ द मोशन. ओके, आणि या सर्व अगोदरच्या नोट आहेत, या सर्व नोट आहेत, 10 नोट्स आहेत. कंपॅरेटिव्ह स्टडी आहे. हॅमिल्टोनियन, लॅग्रांजियन अँड राउथ्स फंक्शनची कंपॅरिझन स्टडी वी कॅन एक्सप्रेस इन द फॉर्म ऑफ अ नोट. ओके, तर ठीक आहे, या ठिकाणी थांबू. नमस्कार, गुड बाय. या नोट मात्र व्यवस्थित सेपरेट लिहून घ्या. कंपॅरेटिव्ह स्टडी आहे. लॅग्रांजिज इक्वेशन, राउथ्स इक्वेशन आणि हॅमिल्टोनियन इक्वेशनची कंपॅरेटिव्ह स्टडी या वेगवेगळ्या नोटमध्ये दिलेली आहे. हे सर्व नोट तुमच्याकडे असू द्या. ओके, ठीक आहे. आता पुढचा पार्ट आपण उद्याला घेऊ आणि रोज सकाळी 9 वाजता असतील. सर्वांनी कंपल्सरी प्रेझेंट राहणं गरजेचं आहे. आज फक्त 22 मुलंच आहेत. मला माहीत आहे तुमचे 80 ॲडमिशन आहेत. 80ला 80 विद्यार्थी पाहिजेत. ओके.